Hello everyone, welcome to this tutorial where we will solve a fun problem, optimizing music selection to maximize happiness or endorphins using dynamic programming. Ever wondered how to pick the best playlist within a limited time? Today, we'll model this as a 0 or 1 knapsack problem and solve it step by step with Python. So, what is dynamic programming? So, before diving into the code, let's understand dynamic programming. Dynamic programming is an optimization technique that breaks problem into smaller sub-problems, solves each only once, and stores their solutions to avoid redundant calculations. Key properties of dynamic programming problems. The first one is optimal substructure. The best solution depends on optimal solution to sub-problems. Second is overlapping sub-problems. The same sub-problems are solved repeatedly. So instead of recalculating, DP or dynamic programming stores results in a table, making it much faster than brute force. Now, let's apply DP to our music selection problem. We have a list of BTS songs, each with a duration or seconds and endorphin value or happiness. Our goal is to maximize endorphins without exceeding a time limit. This is a classic 0 or 1 knapsack problem. We either pick a song or skip it, just like choosing items for knapsack. See in the upper right, Spring Day gives 500 happiness but takes 500 seconds to play. Is it worth the time? Well, we will let DP decide. So first, we initialize table. We start with all zeros, means no songs means no happiness or 0 happiness. The step 2 is fill the table. At each step, we decide if we include this song. If yes, combine its value with remaining times best. So if no, keep previous best. Step 3 is backtrack selections. Now we trace back from the final cell like treasure map to find which song made the cut. While this part of the code generates a comprehensive report of our music optimization solutions, first it prints a formatted table listing all songs with their IDs, durations, and endorphin values. Next, it displays a partial view of our DP matrix showing maximum happiness values at 500-second intervals, with columns representing cumulative song additions and rows showing increasing time limits. It then demonstrates a progression of maximum happiness by printing how the endorphins values increase as we considered more songs from 1 to 10 within the 5,000 second constraint. Finally, it reveals the optimal playlist by backtracking through the DP table, outputting the selected song titles, their total duration, and ensuring it doesn't exceed the limit, and the maximum achievable endorphin values, giving us both the final solution and key computational insight that lead to it.
The function listening durations now includes total durations. It focuses only on the total endorphins and the list of selected songs for each listening durations. For the constraints, for the durations, 8,000 seconds only allows songs shorter than or equal to 400 seconds. 15,000 seconds includes the 2 longest songs. 18,000 seconds only includes songs with the endorphins at least 200. For the 25,000 and 30,000 seconds, no restrictions, meaning all songs are eligible. A 2D table is used to calculate the maximum endorphins for each durations. For the rows, it represents songs considered one by one. For the columns, it represents the available time for the playlist. So, Songs are either included if they are fit sa isang constraints. Backtracking for selected songs. Once the DP table is filled, the functions backtracks to figure out which songs were chosen for each durations. Print listening duration report. So in this, we will just print the listening durations results with constraints and the durations, totals, endorphins, and selected songs para makita natin kung ano ba yung total ng endorphins and yung selected songs. As we run the code, so the durations and the total endorphins and selected songs are shown. So for the durations 8,000, so the total endorphins of the durations of 8,000 is 1,800. So for the selected songs, it results the Dynamite, ON, Blood, Sweet and Tears, Butter, Black Swan, Fire, Save, Boy with Love. And for durations 15,000, so the total endorphins are 1,800. For the selected songs, Dynamite, ON, Blood, Sweet and Tears, Butter, Black Swan, Fire, Save Me, Boy with Love. So for the durations 18,000, the total endorphins are 2,100. For the selected songs, Spring Day, ON, Blood, Sweet and Tears, Butter, Black Swan, Save Me, Boy with Love. So the durations 15,000, the total endorphins is 18,000. So the selected songs for that is Dynamite, ON, Blood, and Sweet and Tears, Butter, Black Swan, Fire, Save Me, and Boy with Love. For the 18,000, the total endorphins are 2,100. So the total the selected songs for that is Spring Day, ON, Blood, Sweet and Tears, Butter, Black Swan, Save Me, and Boy with Love also. For the durations 25,000, so the total endorphins for that is 2,450. And the selected songs are Spring Day, Dynamite, ON, Blood, Sweet and Tears, Butter, Black Swan, Fire, Lives Go On, Save Me, and Boy with Love. And for the durations 30,000, same with the 25,000 durations, so the total endorphins for that is 2,450. And same with the 25,000 durations, so the selected songs for that is Spring Day, Dynamite, ON, Blood, Sweet and Tears, Butter, Black Swan, Fire, Lives Go On, Save Me, and Boy with Love. As we run the code, so the durations and the total endorphins and selected songs are shown.